Okay, as you look at the first set of your exercises that you're going to have to do on section P1, it says in exercises 1 through 4, it says list all numbers from the given set that are A, natural numbers, B, whole numbers, C, integers, D, rational numbers, and E, irrational numbers. So as we go ahead and look at this problem right here, we're going to have to go ahead and kind of familiarize ourselves a little bit with these sets. And so if you look back in your textbook and you go to page 3, it talks about the different subsets of numbers that you can be running into. So you'll notice that the first subset of numbers are what's called your natural numbers. Now your natural numbers are those numbers that are used for counting. So in other words, if somebody asks you to count for them, naturally you just go ahead and say 1, 2, 3, 4, 5, 6, so on and so forth. So the natural numbers are those that come to you naturally. That's how I remember this set. Now your whole numbers are all those natural numbers, and it also includes 0. So you've got 0, 1, 2, 3, 4, 5, so on and so forth. Now the integers are all those whole numbers and their opposites. So notice we're going to be putting in the negatives here. So the negatives are also included in your integers. So your integers include -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on and so forth. Now the entire set that encompasses your natural numbers, your whole numbers, your integers are what are called rational numbers. And rational numbers is any number that can be expressed in this form of A all over B. In other words, it can be expressed as a fraction. So there's lots of numbers that can be expressed as a fraction. Of course, all your natural numbers can be expressed as a fraction. So don't forget your natural numbers are included in this set right here. Your whole numbers are also can be expressed as fractions, so can your integers. And so you're going to notice the book points that out to you by going and pointing this out to you right here of those natural numbers that can be written as that. And they also remind you that they can also be terminating or repeating decimals. So remember any decimal that is terminating, so they give you an example here of 0.4, and any decimal that is repeating like 0.6, and notice that little bar on the top of it means that it is repeating. So those are all your sets. Notice they encompass each other, so the book kind of uses this diagram to illustrate that. Now your irrational numbers, there's any number that can't be a fraction. So this is any number that can't be a fraction. So any number that can't be a fraction is in this listed right here. So that includes the set of all numbers whose decimal representation are, and then notice they put down neither terminating nor repeating. And so they give a classic example of this, of course, is pi, which is 3.142. And then they also remind you that all of your imperfect squares fall in that category. So you're looking at stuff like the square root of 2, and the square root of 3. Let's see if I can get my pen to write here. But notice the square root of 4 is not in this list because the square root of 4 equals 2, which follows in that other list. So of course, then you have like the square root of 5. So you're going to notice this also includes like the square root of 5, the square root of 6, the square root of 7. And notice, but when you get to the square root of 9, this isn't included on your list because the square root of 9 can be reduced to equals 3, which is a fraction, which is a fraction, so it falls in that other list. So that kind of gives you your different subsets.